So molecular docking server opens up something like this. Go to docking and you'll find a page like this. Obviously you have to upload your protein and your ligand. Very straightforward. This is one I've already done, so I'm going to repeat it. I'll just go through the first few steps. Uploading the protein. Pretty obvious what happens here. Choose your file and upload it. Going to ligands is exactly the same procedure. So upload ligand. This is one that's already there. I'm going to upload it. It's a bit slow today. Same thing anyway. Ligand, choose it, upload. I'm not going to upload it, as I say, it's already there. Go to my dockings and select start docking. So you'll have the choice to select your ligand. Next. And you will select your protein as well, when it can be bothered. Here we go, tyrosine phosphatase. Please select protein. I forgot to select it, didn't I? There it is. These are part of the protocols for the calculation. Unless you're really sure what you're doing, best to leave them alone until you have a bit more experience with the docking server. I'll mention that in the tag as well, that's quite important. So if you click start at this point, this can take a while. It can go quite quickly sometimes, it can take a while. It is running at the moment. You'll see a series of updates going through the setup process. It's running already, so that's quite nice. If you see the word confirm anywhere, which you might do when you're selecting your ligands and proteins, for instance, just click yes. Okay. So this is the result. This is the one that I chose actually because it's the clearest one of all. There were several results, but this one I like. These are very good values here. Happy with that. Happy with that. If you're not quite sure what that is, it's worth checking up on. It's quite useful. You could also download this structure into, say, Discovery Studio, Avogadro, Chimera, Pymol, whatever your molecular modelling is. That's the ligand in there, and these are the interactive side chains. And so, what can we do with this? The actual model is not, the graphics are not that easy to manipulate. Left click will move it, but as you can see it's not very fluent. I'm going to try and zoom in using the scroll button. It doesn't like that much either, does it? Here we go. I'm just going to turn it around a little bit. And for some reason, carbons of the ligand are depicted in this very peculiar green colour. So I'm going to change that. Oh, happy with that, that'll do. And change it to balls and 6. I'm going to try and impose a Van der Waals surface on this. You can see that this model has a couple of molecule has a couple of fluorines, and it's a difluoro model. So this is where it gets tricky. Right click and surfaces, and that hasn't worked. Right click again. These are not easy to use. Here we go. Van der Waals. You can see it's imposed a Van der Waals surface there. Right click again. Surfaces. Go away. Colour. Oh dear. This is not very helpful. Here we go. Going for colour. Surfaces. Choosing white. So, I'm not saying very much, am I? It's because I can't walk and talk at the same time doing this. And because it's not particularly easy to this is looking quite hopeful. Yeah, I like the look of this. You can see how that is nesting quite nicely in the active site. That would be a screenshot for me, I think. I quite like the look of that. Looks like a sulfur in there, so it's going to be a cysteine, isn't it? Yep, there it is, look. So, going back to the top of the page there, select interaction table, 2 hydrophobic bonds and a load of strange ones over here. You'll notice that the model on the left will illuminate depending on which residue you're highlighting, bond you're highlighting. And something I found very useful in the past is the hydrogen bond plot. Now this is a bit awkward and complicated. You might not want to go this far. You might be happy with the results that you got with your binding affinity. And if you go for this, you will have to read these papers here. I'm not going to go into it too far, but very briefly, these are hydrogen bonds that are either transient, such as here, or they're permanent along this diagonal. These are alpha helices, and these are beta sheets, and these are obviously interactions with the residues. So, briefly, what's happening is as the ligand approaches the active site, it doesn't contact every interacting residue immediately, simultaneously. It obviously takes a little while to make the links, the bonds. So that's really what's happening here. It gives you a kind of snapshot, a series of snapshots of the ligation. It is quite complicated, and you might not want to use it, as I say, but I've once or twice it's predicted, strongly suggested some aspects of the enzyme that were not in the literature, which was obviously very useful in the report. Probably got a few brownie points for that. So that's just about it, I think. Yeah, enjoy.